The second derivative can also be used to identify local or relative extrema through what is known as the second derivative test. So given that the second derivative is continuous near the particular value x sub 0, then first, if the first derivative at x sub 0 is equal to 0, and the second derivative at x sub 0 is greater than 0, then f has a local minimum at x sub 0. Take note of this. The second derivative at x sub 0 is positive, meron tayong local minimum. Okay? Positive minimum. Then secondly, if the first derivative is equal to 0 and the second derivative is less than 0, then f has a local maximum at x sub 0. So less than 0 meaning negative, then it has a local maximum. Negative to maximum. Let's consider this graph. By visual inspection, we can see that f prime of x equals 0 at E, G, F, and H. We can also see that at E and at G, f double prime of x is negative kasi concave down siya. At F and H, f double prime of x is positive kasi concave up siya. Thus, we expect the local maxima to occur at E and G, while we expect local minima to occur at F and H. Ngayon, gamitin natin yung second derivative test to show this. So, given the function, determine the local minimum and maximum values of f. So, for our solution, let's first determine the first derivative. So, f prime of x is equal to 3/5 of 5x raised to 4 plus 3/2 of 4x cubed minus 3x squared minus 6x. Or that is equal to 3x raised to 4 plus 6x cubed minus 3x squared minus 6x. Or in factored form, that is 3x times x minus 1, x plus 1 times x plus 2. Second, let's determine the zeros of the first derivative. So by equating it to 0, so we have f prime of x, so that is 3x times x minus 1 times x plus 1 times x plus 2 is equal to 0. And how do we find out the zeros? We equate everything by 0. So this is at 0. Ito naman is at positive 1. Ito naman is at negative 1. And this one is at negative 2. Therefore, our zeros are 0, 1, negative 1, and negative 2. Next step, we determine the second derivative. So by the first derivative, ang ating second derivative now is 12x cubed plus 18x squared minus 6x minus 6. Next step, we evaluate our second derivative using the zeros of our first derivative. Note that our second derivative is equal to 12x cubed plus 18x squared minus 6x minus 6. And our zeros are negative 2, negative 1, 0, and 1. So f double prime of negative 2 is equal to negative 18. F double prime of negative 1 is equal to 6. F double prime of 0 is equal to negative 6. And f double prime of 1 is equal to 18. Thus, meron tayong local minimum at x equals 1 and at x equals negative 1. Kasi f double prime of x is greater than 0. So, local mean ito, local mean din ito. And for f double prime of negative 2 and f double prime of 0, we have a local maximum. Local maximum din to because f double prime of x is less than 0. Finally, we solve for the local extrema values. For our local minimum, f of negative 2 is equal to 4/5 and f of 0 equals 0. For our local minimum, f of negative 1 is equal to negative 11 over 10 and f of 1 is equal to negative 19 over 10. For the last example, given f of x equals 6x raised to 4 minus 8x cubed, let's determine the local extrema values of f. So for our solution, we first determine the first derivative. So f prime of x now equals 24x cubed minus 24x squared. Next is we determine the zeros of f prime. So f prime of x is actually equal to 24x squared times x minus 1 in factored form. So equate lang natin yung 24x squared times x minus 1 to 0 by equating each factor to 0. So dito, ang x natin is equal to 0. And in this one, ang x natin is equal to 1. Therefore, our zeros are 0 and 1. Then next, we determine the second derivative. We know that the first derivative is 24x cubed minus 24x squared. So our second derivative is, we have 72x squared minus 48x. Then for our fourth step, we evaluate the second derivative using the zeros of the first derivative. Our second derivative is 72x squared minus 48x, and our zeros are 0 and 1. F double prime of 0 is equal to 0, and f double prime of 1 is equal to 24. Thus, there is a local minimum at x equals 1. So, meron tayong local minimum dito kasi f double prime of x is greater than 0. However, for this case, hindi natin masasabi kung local minimum ba siya or local maximum kasi wala naman tayong f double prime is equal to 0. We only have positive and negative values. However, kung babalikan natin yung first derivative test, makikita natin na decreasing siya dito at decreasing din siya dito. Okay? So, wala tayong change. Therefore, there is no local extrema at x equals 0. Only at x equals 1. And finally, solving for the local extremum value, the local minimum is f of 1 equals negative 2. So this example illustrates a very important fact. That is, we cannot derive conclusions from the second derivative test if equal to 0. So wala tayong conclusion sa second derivative test. Therefore, anong gagawin natin? We will use the first derivative test for f double prime of x sub 0 equals 0.